Okay, so we're going to talk about vectors. Vectors are great. Vectors are used all over the place. They're very, very practical in their application, and they really, really are used in almost every single industry in some way, shape, or form, especially if you're trying to describe an amount of something. So, what's a vector? As you saw from the video, a vector is a way of describing anything from point A to point B. Okay. Now, often this takes place in physical distance. Okay, so you can imagine somebody at point A and at point B. And a vector basically tells us how we get from point A to point B. Because let's say this is 5 centimeters. Okay, saying to get from A to B is 5 centimeters. Well, that's fine, but of course, you need to know exactly what direction that you need to go. Okay, and so obviously the direction is going towards B from A, but then again, how do you write what direction it is? Now, you could, if you wanted, I think you guys have seen this before, you could do bearings, but bearings, um, the difficulty is that they're only really used for things like navigation, large scale navigation, not necessarily for short scale navigation, if that makes sense. So we don't use we don't use we don't use that. So instead, what we do is we actually split the vector into two different parts. Whoops, we split it into an across part, so how far you go across, and how far you go up. And this is how we write the vector that is. So let's say, for example, I'm going across by 4 and I go up by 3. Okay, that will take me to B from A. Even if I would not go directly from A to B along this vector right here. Even if I went across 4, then up 3, it would still be the same result. So vectors have one of these odd attributes that it doesn't matter which way round you go. If I had another vector, let's say I had another way of getting from A to B that goes like this. Okay, and that every single one of these lines is made up its own vector, then the resultant vector would still be the same. Okay, it would still be the same as this A, B vector. So how do we write this now from the video? You should have seen that this is 4 across and 3 up. Generally speaking, not generally speaking, always speaking, the number on the top describes the sideways movement, and the number on the bottom describes the vertical, so the horizontal and the vertical. If the number on top is positive, then it means go right, and if it's negative, it means go left. And if the number on the bottom is positive, you guessed it, it goes up. And if it's negative, you guessed it, it goes down. Okay, so if I wanted the vector a, B. Okay, that's one way of writing my vector. I can't write a bold A. I could do, but it doesn't look very nice. So it's useful on computers, but nothing else. So usually I'll use this kind of notation up here. So if I wanted to write the vector AB, that equals 4, 3, and that's just exactly how you would describe it. Okay, BA, as in we're going from B to A, well, we just need to think, okay, well, how do we get from B to A? Well, I can see that I need to go, well, do I go down first? Well, at this time, I've got two different options. Let me just get rid of some of these things. I've got two options really. I can either think of it as I'm going to go back along the same path. I'm going to go down 3 and across and left 4. But, you know, that does help a little bit here. I mean, I could go -3 and -4. But just to make it a little bit more visual, I think I'm just going to go instead, I'm going to read it as I would read a vector, -4, -3. So what does that mean? Well, -4 means go across left by 4, and -3 means go down by 3. 4 centimeters, 3 centimeters, 4 centimeters, and 3 centimeters. So you can see again that the resultant vector is exactly the same if you go left 4, then down 3, or down 3, then left 4. Now, this is a regular. This is actually quite an easy vector to work with because sometimes you do get asked, well, what's the magnitude of the vector? And this is a lot easier than it actually sounds because all you need to do is use a little bit of Pythagoras. So if you've got a vector for 3, then I know it's going to be 4 across, 3 up. Oh, and look at that, it's actually a right angle. So we all know that Pythagoras, the wonderful man that was, he told us that if you've got a right angle triangle, you square both sides, add them together, and then you square root it to get the hypotenuse. So 3 squared plus 4 squared equals our magnitude squared. And in this case, 3 squared is 9, plus 4 squared is 16. I'll just call that m squared. So 25 equals m squared. Oh, look at that. 5 equals m just by square rooting both sides. Okay, so that's how we find the magnitude of a vector. Nice and easy. I just want to draw your attention now, though, to some more interesting stuff, really. And that starts on page 230. So now I'm on page 230, and I'm looking at adding vectors. Okay, now let's say, for example, I'll use the same one as I had before. I've got that 5 vector there, which is a 4, 3 vector, A, B, and I want to add another vector onto there, okay? And this new vector is also going to have a magnitude of 5, but it's going to be the vector BC. Now, to get from B to C, I know that I'm going to go across 4, but down 3. Okay, that's going to be my BC vector. That's something that I've chosen to be correct. Now, if we think about it, we're going to go up across 4, up 3. And then we're going to go across 4 and down 3. Okay, now if we want the vector AC, well, this is what we call the addition of vectors. And all we do is we want to find the resultant vector AC. Now, it should be pretty clear that, well, if I've gone across 4 and up 3, and then across 4, then down 3, then to get from A to C, I just go across by 8. So we know our answer is going to be 8, 0. But how do you do it in actual vector form? Well, it's nice and straightforward. In fact, it's super, super easy. It's AB plus BC. You go from A to B and then from B to C. Okay? And that equals AC, the resultant vector. How do you work it out with the numbers? Easy. 4, 3 plus 4, -3 equals That's our AC. Well, how do we do that? Well, we just add those numbers and we add those numbers. Real easy. Okay, so that's 8. 4 plus 4 is 8, and 3 minus 3 is 0. Super, super simple. Okay, so now what if we have something called a scalar vector? Okay, when it's multiplied by a number. Okay, so let's have a look at the vector a, b again. And I do it 3 times, oops, not equals 3. And I do 3 times AB. Okay, you can do this really, really easily because this is literally, it's AB plus AB plus AB. So that should be relatively straightforward, but all we need to do is just multiply all the numbers in our vector by 3. So I'm going to get 3 times 4 and 3 times, not negative 3, just 3, which is 12, 9. And what does that look like as my actual vector? Well, there's my first vector, and it's the same thing. It's just a lot further. And you can see that it's either that, plus that, plus that, or the resultant vector of 3AB is all the way across there to 12, and then up to 9. So that's how you multiply vectors by a scalar. You can have negative numbers as well, and what that does is actually just changes the direction. So for example, if I want to go from B to A, okay, well, we know that that's going to be -4, -3, okay, because we need to go left 4 and down 3. But that also equals -1 times 4, 3. So negative AB equals BA. All right. So if you've got a negative, if you times a vector by a negative, essentially you go along the vector, but the other direction. So if we look at this original vector up here, yeah, AB would be that. Negative AB would be going the other direction from B to A. Okay. So this is multiplication of a scalar. This is also addition of vectors. Vectors are really, really straightforward. All it is adding numbers together and finding out correct routes from one point to another. Now, there's one more bit that I do want to talk about as well, and that's if a vector is collinear or parallel to another vector. Okay, so if I've got a starting point A and a vector going to B, and the vector is, let's change a different one this time. Let's have, I don't know, 7, 4. That's my vector AB. And I want to know if this vector down here is parallel, to AB. Okay. Now, how are we going to know it's parallel? Well, if it's the same as this vector, 7, 4, then obviously it's going to be completely parallel. It doesn't matter where we're starting from, but it's going to be the same direction, across 7, up 4. And this one also is across 7 and up 4. So those two must be parallel. But also, what if I had another one, EF, a much larger vector, but the vector itself, so that's CD, the vector itself, EF, equals 21, 12. Okay, much larger vector, much larger magnitude. But I can see that 21 and 12 have a common factor of 3. So I can take that 3 out of that vector, and I can get 7, 4. So because this vector here of 7, 4 is the same as those two vectors there, I know that this vector EF is parallel to the other vector as well. Okay, so any multiple, any scalar multiple of one vector is parallel to any scalar multiple of the same vector starting at anywhere else. Okay, so all they need to be is a scalar multiple of each other.